A review on different fax devices used in electrical power system. Abstract: with rapidly increasing industrialization and urbanization, electric power demand is increasing. Power system is subjected to supply these loads without interruption. Sometimes disturbances such as system faults, sudden addition or removal of large load, etc. cause instability in power system. There are chances of power system failure if these disturbances are not cleared. Flexible AC transmission system, FACS, technology is used to compensate parameters due to disturbance and helps to improve system stability. This paper is about a brief description of different FACS devices like static synchronous compensator, STATCOM, static VAR compensator, SVC, static synchronous series compensator, SSSC, thyristor controlled series capacitor, TCSC, unified power flow controller, UPFC, and interline power flow controller, IPFC. Keywords: FACS, real power, reactive power, voltage source converter, VSC. Introduction. Electric power system consists of three parts: generation, transmission, and distribution system. Power plants are situated nearer to fuel storages. Usually, electric loads are far away from generating units. Transmission lines transfer power from generating unit to load center. Transmission occurs at high voltage or extra high voltage level 1. With rapidly increasing industrialization and urbanization, electric power demand is growing continuously. This is causing more stress on existing system. Electric power systems are interconnected through transmission lines to form power grid to overcome this issue. Power grid helps in increasing diversity of load, sharing available resources and operating generating units economically. It improves power system efficiency and reliability too. A stable power system remains in equilibrium under normal operating condition and regains its new acceptable state of equilibrium after disturbance. It supplies power uninterrupted. Disturbances like system faults, sudden addition or removal of load, etc. makes system unstable. There are chances of system failure if effect of these disturbances is not cleared out. System failure is unwanted and uneconomical. Flexible AC transmission system, FACS, technology is used to overcome disturbance effect. FACS devices consist of power electronic devices and controllers. Purpose of FACS devices is to improve power system stability is by controlling system parameters such as voltage, V, power angle, D, and series impedance, X, with help of voltage source converter, VSC, which is inverter. FACS devices are classified as I, shunt compensating devices, 2, series compensating devices and 3, combined devices. Some FACS. Dr. Anita A. Bhole. Electrical Engineering Department. Government College of Engineering. Aurangabad, India. Devices like STATCOM, SVC, SSSC, TCSC, UPFC, and IPFC are used to control real and reactive power through system 3 to 15. 2 power flow equation in 2 machine system. Vs equals V. dx Vr equals V.0. In 2 machine system, voltage at sending end, Vs. Voltage at receiving end, Vr, phase angle difference, D, end. Impedance of transmission line, X, power equations are expressed as real power depends upon phase angle D and reactive power depends upon voltage 1 to 2. 3. STATCOM. STATCOM is a shunt compensating device. It feeds static reactive power in parallel with transmission lines through connected bus. Different components of STATCOM are I, DC energy source such as battery or capacitor bank, 2, VSC i.e. voltage inverter to convert DC supply into AC supply, 3, control unit to generate pulses for inverter with the help of pulse width modulation, PWM, technique, 4, transformer to link output voltage to line voltage. During disturbances, STATCOM supplies reactive power requirement. It improves voltage stability. 3. V. INV. Coupling. Transformer. VINV. VSC. VDC. Where VINV and V1 are inverter output voltage and bus voltages respectively, and X is reactance of line from inverter to bus. When system bus voltage, V, reduces i.e. V-VINV, STATCOM supplies reactive power required acting as a source. When system bus voltage, V, increases i.e. V-VINV, STATCOM absorbs reactive power acting as a sink. When both voltages are equal i.e. V equals VINV, reactive power transfer doesn't take place. Thus, reactive power compensation is done to control voltage at bus and through transmission system. 4. STATCOM shows constant current characteristics. First quadrant of graph shows inductive mode while second capacitive mode. For SVC. SVC is shunt compensating device. It supplies required reactive power to bus connected in parallel. It consists of I, capacitor which is either fixed or switched with help of thyristor, 2, reactor which is controlled by thyristor, 3, control unit to generate signals and 4, coupling transformer 5 to 6. Slope of line OA gives susceptance of capacitor indicates capacitive mode of operation and slope of line OBC gives susceptance of reactor indicates inductio mode of operation 1. SSSC. SSSC is a series compensating device. It controls real power flow through transmission line. Different components of SSSC are I, VSC to convert DC into AC supply, 2, DC energy source, 3, controlling unit and 4, series transformer to connect it with line 7. Fig 6. Basic configuration of SSSC. Sinusoidal voltage V, 90 degrees out of phase with line current, is fed to transmission line. When voltage leads by 90 degrees, it gives inductive reactance. When voltage lags by 90 degrees, it gives capacitive reactance. Power transfer capacity of line is controlled with injection of series voltage which changes impedance of line 8. 6 TCSC. TCSC is series compensating device. A capacitor is in series with transmission line. Thyristor controlled reactor, TCR, is in shunt with capacitor. Value of capacitance is varied by connecting inductive reactor in parallel with the help of thyristor. TCSC has capability of proving positive as well as negative reactance. It changes overall impedance of transmission line. Power flow is controlled by varying impedance 9 to 10. 7 UPFC. UPFC is combined series shunt device. 2 VSCs are used, one connected in series with transmission line and other in shunt. These 2 VSC are connected through a common capacitor. Capacitor keeps voltage across VSC constant 11. 1 inverter control reactive power through shunt transformer for voltage improvement as STATCOM. Another feeds symmetrical voltage through series transformer to control impedance and phase angle as SSSC. Thus, UPFC controls both voltage enhancement and power flow 12. BUS1. BUS2. Series shunt transformer. DC link. SSSC, STATCOM. Fig 8. Block diagram of UPFC. 8 IPFC. IPFC is a combined compensating device. It controls power flow through transmission system having multiple lines. SSSCs are used to transfer real and reactive power in between transmission lines 13. VR1 BUS2 BUS1. BUS3 VR2. Typical 2-line IPFC has 2 SSSC connected to a common capacitor. Series transformers are used to couple outputs to transmission lines. Injection of series voltage with line voltage controls real power flow. IPFC shifts load from overloaded line to underloaded lines. This helps to overcome resistive voltage drop across transmission line. It helps to improve voltage level. As voltage affects reactive power gets improved 14 to 15. 9. Conclusion. There are different fax devices used to improve power system stability under disturbances. Shunt fax devices such as STATCOM and SVC improve voltage stability by reactive power compensation and keep voltage at bus nearly constant. Series fax devices like SSSC and TCSC are used for real power compensation. While both real and reactive power compensation is achieved from combined devices like UPFC and IPFC.